Hey folks, this is lab number 9, and we're going to talk today a little bit about recursion. This is exactly the same in both languages, so I'm giving just the same video to both of you guys. I'm going to do the example in Java, but it is literally identical in C#. With regard to recursion, generally you're going to want to address each of these problems in the same way. So in this one, you're trying to write recursive multiply. This time you're writing recursive divide, recursive mod. You're always going to ask yourself the same thing each time. The first question is, what is the base case? What is the simplest circumstance? If you're asked to multiply something by 0, the answer is always going to be 0. That's a simple answer there. For recursion, or for division, if you're going to divide something by 1, the answer is going to be the same as what it was originally. So 7 divided by 1 is going to be 7. So anytime that you're dividing by 1, the answer is the original number. And so that's a base condition. You always have to ask, what is the simplest case? Once you figure that out, it's then just a matter of figuring out how the other cases add on to that. So what I'm going to do for an example today is I'm going to use replit, and I'm going to write a recursive method that adds up all the numbers up to a certain number. And so what I specifically mean is I'm going to create a method here, which is going to be public int sumNums, and it's going to take in a maxNum. Okay, so what I mean by this is, and I'm just going to put in a comment, if maxNum is equal to 0, then this is going to return 0. If it's 1, then it's going to return 0 plus 1. If it's 2, then it's going to return 0 plus 1 plus 2, and so on and so forth. All right, so the base condition is that first circumstance. It is the simplest possible case, because we know what the answer is in that case. So if maxNum is equal to 0, then we're going to return 0. All right, in the other cases, else, we need to figure out what it is that we're going to return. But before I go any further, what I'm going to do is I'm going to have a return 1 in here just so that it gets rid of that error message. And I'm going to go ahead and test out this method as it is now. So I'm going to type int answer equals sumNums, and we're going to pass it a 0, and we would expect that that's going to return the number 0. So there's answer plus answer. All right, and to make a reference, okay, has to be a static method because it's inside of it's being called from a static method. That's true in Java and C#. You always have to put that static in there if you're going to use methods in the main method. All right, so we get back answer equals 0, which is what we wanted. Okay, so in all other cases, if we were asked for the sum, or for maxNum being equal to 1, then it's whatever the answer from the previous one was plus 1. All right, and so how do we go about doing that? So we're going to return whatever we got from the previous one, which is sumNums maxNum minus 1, and we're going to add to it maxNum. Now, how did I get there? So, well, let's first test it. All right, so let's pass it in 3, and we would expect that to return 3 plus 1 is, or 3 plus 2 is 5, plus 1 is 6, so that should return the number 6. It did. Let's do 4, and that should return the number 10, because 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. And it looks like it did. Great. So how did I get there? Well, I realized that in the case of num equals 2, that's this, I needed to add 2 to whatever I was doing before that. In the case of 1, I needed to add 1 to whatever I was doing before that. Oops. And in the case of 0, we knew what the answer was. So that's what I did. If I expand this out one more, maxNum equal 3, then the answer is 0 plus 1 plus 2 plus 3. So on the first call, it's going to take this 3, and it's going to add it to whatever this is, which is sumNums of 2. Well, we know that sumNums of 2 is going to be 2 plus whatever this is, which is the same as sumNums of 1. Well, we know that that's 1 plus whatever this is, which is the same as some nums of 0, and we know that's 0. So now all of those plug into the previous one, and you end up with your answer. So that's how you go about solving each of these problems. You have to identify 3 things. The first thing is, what is the base condition? What is the simplest possible circumstance that you are being asked to solve for? In the case of multiply, that's going to be you multiply something by 0, the answer is 0. Or it could be 1. If you multiply anything by 1, the answer is whatever the other number was. So 7 times 1 is 1. Is 7. So you could use either of those as a base condition. The simplest possible case is going to be the base condition. The second thing that you have to figure out is, what is the recursive call going to look like? The recursive call is this part. That's where I'm calling myself, I'm calling the method sumNums. I need to be passing it something that is changing the parameter that I have. If I'm not changing that parameter, it's just going to keep going forever and ever and ever because I'm never going to reach the base condition. And specifically, I have to be able to give it a number that is moving me closer to the base condition. So if the base condition here is that sumNum equals 0 or maxNum equals 0, then I better be changing this to a smaller number each time through. All right? Then the last part that you have to figure out is, what math are you doing to it, or what are you trying to add to that, or subtract from it, or divide from it, or multiply to it, or whatever the case may be. And that's the last part. That's the part that's the more tricky part, which is, how are you actually getting closer? So this is, go 1 backwards and add to it the current value. Now, this is a valid answer to this question, but I will point out that it has a bug. If I ask it to sumNums -1, what's actually going to happen is it's going to crash. And that's because it starts off at sumNum -1, and then it goes to sumNum -2, -3, -4, -5, 6, 7, 8, 9, blah, 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 and it eventually just runs itself out of memory and crashes, which is what happened there. So this is not perfect. It works as long as sumNums is given a positive number. And so change that back to 5, and life should be good again. If you wanted to avoid that, you'd need to put in another condition up here that checks for that situation. So if maxNum is less than 0, then print out oops. All right? And so now I'm going to pass it in -1, and that is going to, this needs to become an else if at that point. That is now going to just say oops, and that's going to be that. Okay, so that avoids the negative problem. All right, so today you are going to, what did I do? Line 20, I'm missing, else if, that. Yeah, I'm not sure why I'm missing a curly brace. It says that one is not matched, but it is matched. That one matches that, that one matches that, that one matches that, and that one matches that. Yeah, okay, I'm not really sure what I just did that messed that up, but somehow I made that angry. Either way, the important part of all of this is that in your code, you are going to start off and figure out what the base condition is, and then figure out what your recursive call is, and then figure out what you're doing to that recursive call to get you to your final answer. Okay, I see what it's complaining about. This doesn't have a return statement, and the method is supposed to return an int, so I need to return something. And so it wasn't allowing me to continue because I just printed out something. I wasn't giving it a return. So that's the correction there. All right, well, that's it for today's lecture. Hopefully that gives you a good place to start. You're going to do some coding on various different recursive methods, and I will see you guys next week.